Dora, you can learn it, or unless you want to, quickly run and come back.
Same thing.
Hurry up. Come prepared. Alright, here we go. Exercise 6J. Let's do an example. Now, the 11's listening. When you're doing chapter 6, these are the skills that you need. You need to be able to use factor theorem first to find out your factor. You need a linear factor before you could then divide. So that was a skill on your homework sheet that I gave you. It's due today. After that, your next skill is chapter 3, factorizing quadratics. So there's a lot of different ways. Perfect squares, perfect cubes, which you learned in 6C. Okay, you're going to learn how to factorize quadratics. And that could be difference with perfect squares or completing the square. You also have cross method there. And then finally, once you got all your brackets out, null factor to solve. Now that's exercise 6D. Yeah, so all of that is really C, B, chapter 3, D. That's the order that you've always been doing so far. So all my homework sheets, that's what it is, right? Your remainder theorem, I've got an extra worksheet for you to work on so you can practice finding A and B's. I've done that in your homework sheet as well. One of the questions you have to simultaneous. That's where it gets tricky. But other than that, everything else is now sketchy. Everything else now is analyzing the equation. So today's exercise, your job is to read the question and apply all those skills. Okay, but you can use a CAS, right? So here we go. Let's look at this question. Pretty straightforward. I'll do this one with you, and then I'll get you to do the next question, question 1 of exercise 6J, so you can practice and see how you're applying it. Okay? So here we go. We've got a square sheet. We've got a square sheet of 10. It measures 12 by 12, so this is what I know. From here to here is 12, from here to here is 12. It's a square sheet. But I'm obviously missing corners. So I'm missing this part of the corner of the sheet. I've got 4 of those corners there that I'm missing. What they tell me is 4 equal squares of edge x centimeters have been cut off. Okay, so I've got 12 by 12, and now I'm cutting off x. I'm cutting off that square, right? And I'm left with the box, or this tin. Now from this tin, I'm now going to then fold it so that it becomes a 3D box. So if you can imagine, if I do some dotted lines here so you can see, this is where I'm going to fold, and it'll look like this. If you fold it up, all the corners up. Oh, wow, that's badly drawn. But there you go. You got a box, okay? This folds up and you got that flap there. These flaps close together and that's the back flap, right? So I've got an open box. My question here says, find the values of x for which the volume is 100 cubic centimeters. Now, when you're doing these questions, use what they've given you. Okay, use what they've given you. So far, they want you to find volume. Now, you think about it, how do you find the volume of this rectangular box again? Back in year 7, 8, 9, you learned how to find measurements. You learned how to find the volume of a rectangular box. How do you find the volume of a rectangular box again? How do you do it again? Ben, how do you find the volume of a rectangular box? Yeah, that's it. Length times width times height. Or if you remember, it was the area multiplied to the height. But in our case, we've got a rectangular box. Okay, and how do you find the area of the base? It is length multiplied to width multiplied to height. Okay, so that's what I'm going to do here. Ian, next time if you want to use it, just let me know. Yeah? I think that's very rude of you what you just did.
Oh.
Yes, we got it. Now you're talking while I'm teaching. Sorry. So Ian, 1, you walked out of my class to get a CAS that you're not prepared. 2, come to my laptop and you insert your phone because, you know, everything's here. You just do it. Didn't need to ask me, you just plug it in. Yeah? Then you go over here while I'm teaching and then you say, that's what happens when you don't bring a portable charger. Fantastic, Ian. I really respect that. Very disappointing in you. And that's just so rude. You just walk in, you do what you want. You normally walk out of my class without letting me know. Well, being very lenient with you, and you have improved. That's not what I want to see. Okay, cool? When I'm teaching now, you listen, and you get yourself prepared, but you don't do that in my classes. Yeah? All right, here we go. We've got a box. We've got a volume of a box. You know its length by width by height. So if I fix this, you now have length times width times height. Your job is to figure out what should the length be, what should the width be, and what should the height be. So if you look at this diagram here, that's the hardest part. Part of A, the hardest part is to figure out the dimensions. Now, if I asked you what this entire length here is, how would you work this one out? So you know this is 12, and you're removing x from the top and bottom. So what is this length here? 12 minus 2x, because this is 12. You subtract, you're losing out x amount here, and you're losing x amount there. So you're losing 2 of these x's. 12 take away 2x will tell you this length here. Does that make sense? Yeah. So if I write it down now, length here is equal to 12 minus 2x. What about width? What would the width be? So if this is my length, what would my width be? 12 minus 2x as well. So now I know width is 12 minus 2x. What about the height then? See the height, when I fold it up, that gives me this height. It has to be x. So if it's x, now I'll put it all together. This is my width, that's my height. Height is equal to x. I can say that's length, 12 minus 2x, multiplied to width, 12 minus 2x, multiplied to height, which is x. And that's a cubic equation right there. You've got one bracket, two brackets, third bracket. X times x gives you the x cubed. Now is this a positive cubic graph or is it a negative cubic graph? It's positive because you take out the negative 2x times the negative 2x becomes positive, and then you times another x becomes 4x cubed. Okay? So what I have right now, I've got a volume A. Volume is equal to 12 minus 2x multiplied to 12 minus 2x multiplied to x. And you can already see negative 2x times negative 2x times x is a positive x cubed. So it's a positive graph. I've got my equation. The question asks you to find the values of x for which the volume is 100 cubic centimeters. What are they telling me here? Fantastic. Absolutely that. Sub in, you know the volume is 100, and they want you to solve for this. Now you can do this by hand, or you can do it by CAS. Okay, so you're literally trying to solve that equation for x.
Could you add 12 minus 2x squared instead of 2?
Yes, you can. You can rewrite this entire thing as 12 minus 2x all squared multiplied to x. That is also possible too. Okay. Now, from here, you want to type in your CAS calculator. Remember I said anything with your CAS, I want you to practice the 3 things I taught you. Define, okay, and you got then solve. Those are the 2 things, and then sketching. Those are the only 3 skills you need, yeah? Now, I'm going to go to my CAS. If you have a CAS, get it ready. We're going to do define. Okay, so define, we got menu 1, 1. So menu 1, 1 is defined. I'm going to define f of x, okay, is my function, equals to, in our case, we worked it out was 12 minus 2 times x, close brackets, open brackets again, 12 minus 2 times x. Now remember, you can do that squared as well if you want. I'm just doing the 3 brackets, times x. Okay? So that's my equation. Define 12 minus 2 times x times 12 minus 2 times x times x. Yeah? What are we trying to do? We're trying to solve for x since we know the volume is 100. So what you're actually doing is you're solving, so menu algebra solve. What are you solving for? You know that the volume equals 100. See what I'm doing there? I'm just saying this is the equation. That's the equation. That's equal to 100. Well, what am I solving for? What am I missing in the syntax? The x. How do I type in the x so that it doesn't come up as syntax error? Comma x. You always have to have the comma. So here we go. Find comma. It's right down here. Under the pi, you got a comma. So comma x. Yep. Which one?
Yeah.
Oh, you don't have to. If you press enter, it'll come in. But it's good habit to put it in.
Oh.
Yeah? So I put the bracket in there. Can you see that bracket there? So I close the bracket, press enter, and it solves for me. It solves for me. That's x equals 1, which makes sense. You can, oh, actually no, you can't tell because you have to move 100 over. But these are your x-intercepts that you just figured out. X where the volume is 100. Now, okay, this is a good question. So, yes, when you're writing your answer, this is what I want you to see. So you got x equals 1. This one here is x equals 2. Now, if you expand the brackets with the negatives, this becomes 11 minus root 21 on 2. And this one is 11 plus root 21 on 2. Now, if you have a look at this, what's the... actually, those are just my answers there. But when you're solving for the volume, you can't simplify this any further. This is as simplified as you can get. Okay, so that's in terms of the surds. You got, as long as the denominator is not irrational, meaning if it's not a surd, this is fine. You can leave the answer there. Okay, so this tells me when will the volume be 100 cubic centimeters. You got x equals 1, so that tells me the dimension. Okay, but the interesting thing is we don't know what this actually equals to. 11 minus root 21 is an exact value. I want to know what that is in terms of length or value. So how do you do that? Does anyone know how to change this to decimals right now? How do you do that?
Press control.
Fantastic. So how do you do it? Move your cursor up, highlight it, press enter so it comes down. Okay, but before you press enter, hold the control button and press enter. So watch what I do. So I'm going to do it again. Highlight it. Now before you press enter, hold the control button and then press enter. Now, if you have a look at this, this tells me that when x equals 1, 3.2, or 7.7 centimeters, this is when you will have a cubic where it has a volume or box volume of 100 cubic centimeters. Okay? How do we go with that? Was it all right? Yeah? Cool. All right, last question. B. It says find the maximum volume. How do you find the maximum volume? It's all CAS work right now.
Find the maximum on the graph.
Fantastic. You have to sketch it. So you defined it already. You don't have to type all the equation again. You can go back to the equation. Now, if you press Control Doc, that adds a page. And I want to add a graph page. So I'm going to go to number 2. Add a graph page. Now, because I defined it on the last page, I don't have to type it again.
How do you?
Control Doc. Yep. And then go to number 2. Now, I'm just going to type in f of x because I defined that in the last step. It makes it easier to do. So from here, if I press f of x and I press enter, I get my graph, right? But this doesn't give me the entire graph because the range, the y values are only up to pretty much 6.67. And that's about 10. I need to go a bit further higher. So there's a few things that you can do to change this now. You can go to menu, and I only teach about 3 things to do. Go to 4 for Windows. Go to 4. I always use these skills here. I use Zoom Fit, I use Zoom Box, and I use Windows Settings. Zoom Box is when you want to move into a graph that's really big and you just want to focus on one section. It zooms it up for you. Zoom Fit. This doesn't always work, but usually what happens is they'll try to fit the graph as best as they can into one screen. Sometimes it works perfectly, sometimes it doesn't. Windows Settings is doing it manually. So you manually adjust it. Okay, so you might want 100 centimeters up or something like that. Okay, so what I always do is what I want you to do. I want you to try Zoom Fit first, see if it works. Okay, so you go again, menu. Okay, in, menu. 4. Yep. And then you got Zoom Fit on the bottom there, which is A. Okay, now if you do Zoom Fit, see what it's done, and it's not the most ideal. They've sketched the entire graph and they try to fit it into the screen as best as they can. The problem is you can't really see this bit here, true? Yeah? So what I normally do is I use Zoom Box. So from here, now you go to menu, 4, Zoom Box number 2, and this is nice because you can adjust wherever you want to see. So I know I just want to see from here to here. And it gives me a nicer graph. See what I'm doing there? So I'll do it again. Once you're going to menu, 4, zoom box, which is number 2, you can choose wherever you want the box to be. So I can do it like this long. If I want it, I could make it this long if I wanted to. And it'll zoom it in for me. Okay, so this is nice because now I can see it's gone up, it's come down.
What's that gonna mean?
This is the graph. This is the volume. So this is, all right, that's a good question that Ian asked. What does this mean when you sketch the graph? Remember, we sketched a volume equation. So it means for every x value you choose here, this is the volume. So you want to find maximum volume, it's the top. Maximum volume is where does it reach the maximum, where's the biggest height that it can reach. Because this is your volume by your x length. That's what you wrote. You wrote v equals 2 and you sketched it. This is what volume is. So whatever x values you choose, how much you cut out the squares will tell you how much volume you get. Now the maximum is somewhere here. Yeah? Now, this graph here is still a bit low. If you want to adjust it even further, this is what you can do. Menu 4, now I taught you zoom fit. I taught you zoom box. You can also do Windows settings. Now if you go to this one, you can manually adjust it. Now it looks like the width is good. It's the height that's an issue. So what I would do, minimum, instead of negative 1500, I might keep it as still 1500. But instead of 1700, I want to reduce that. I want to reduce both of them down to, instead of 1500 and 700 and something, it looks to me, 100 is about here, so maybe I should do 500, 500. And that shrinks it down for me. So that's what I'm going to do. I'm going to change it to 500. And I'm going to change this to 500, or negative 500. Okay, so what you can see is it just makes the graph look a bit nicer. So I keep the same width. It's still the same width, but now you can see the maximum and you can see the minimum coming down here. Okay, so those are the 3 skills that I would use to adjust the graph. And you can use that all the way to year 12 just to adjust those 3 skills. You can use other zooms if you want, but those are the 3 that's worked well for me to be able to adjust the graph. Okay? Now, to find maximum. How do you find maximum again? What do you do? What was the skill? How do you do the maximum here? How do I find that point? Good. Menu. Now we're in menu. Analyze graph. Good. Number 6. And there you go. You got all your points. Now, does anyone remember what the first one does? What does 0 do? 0 tells you, allows you to find the x-intercepts. That tells you the minimum. This tells you the maximum. If you have 2 graphs, that tells you the intersection. Yeah, so I'll show you how to find the x-intercepts. We go to number 1. All you have to do is, let's say I want to find the x-intercept on this left-hand side. I go, click a spot on the left, click a spot on the right, and it tells me it's 0, 0. Okay? So I can do the same thing again. If I want to find the x-intercept on the right-hand side, I go menu 6, 1, and I go over here and I go, all right, let's click here, and then click on the right-hand side of that x-intercept, and it'll tell me. Sorry? Could be any point. As long as it's around that region, it'll find the x-intercept for you. X-intercept. Yep, there are only 2. Right, now to find the maximum, menu 6, 3 is your maximum. And I know the maximum is somewhere from here to here. Somewhere there. So you can click anywhere as long as you pass that maximum area and it tells you. Now, final part, Finn. Thank you. Final part. Most students will be able to do this and sketch it once you're using CAS a bit better. You get this, but you haven't answered the question. What is the maximum volume? So a lot of students make this mistake. What's maximum volume? That's maximum volume based on what I've just done for you guys here. Y value. It's the Y value. And that's the problem. A lot of kids will do this and they go, yes, 2. Okay? So you have to remember that 2 represented your x values. In your problem, that 2 represents your how much you're cutting out. That's your V. Okay? 128 is your volume. So your Y value is your volume. So to answer the question,
So volume is 128.
Yeah, volume is 128, but that's your maximum volume.
So X equals to Y is minimum. Y is volume. Y is. What's the maximum? Minimum is like. Maximum is
Like the top minimum is the smallest value. It's true. Well, you just look at the y-axis. Obviously, is this number bigger than this number? Yeah, so it's bigger, so of course that's the maximum. Okay, well you got to learn it. All right, there we go. What I want you to do now, use what you have just learnt. I want you to try this question. Question 1. Let's do it. Question 1, I'm going to give you a bit of time and then I'm going to go.